If you take a look at the individual pieces of our piecewise function, x squared plus 9 is a continuous function, and 9x minus 9 is a continuous function. And so we need to now take a look at the place in which the two graphs meet up, which would be at x is equal to 3. So we're going to examine the limit as x approaches 3 from the left side of our function. And when we do that, we find that our limit coming from the left will be equal to 18. Then let us examine the limit as x approaches positive 3 coming from the right side. By examining this, which is the other part of our piecewise function, 9x minus 9, and the limit of that, as we come from the right side, is going to be 18 as well. Taking a look at the piece of the function which includes x equals 3, the second piece of our function, so therefore plugging in 3 into that component, we find that our height at 3 is equal to 18. Hence, by the limit definition of continuity, since the limit as x approaches 3, coming from both sides, exists, and in this case is equal to 18, and since the height exists at x equals 3, and that is also 18, therefore our function will be continuous. The next component is we need to check to see whether or not f of x is differentiable. So in this case, we're going to be checking to see if our slopes as we approach from the left and the slopes as we approach from the right approach the same particular value. Now, we've already determined that this function is continuous at 3. And now we're going to take a look to see what the limit of our slopes are approaching as we come from the left side. So let's take the derivative of our first function, which was x squared plus 9. And its derivative is 2x, evaluated as we approach positive 3 from the left side. It approaches the value of 6. And the limit of our slopes of f of x as we approach 3 coming from the right side would be as of the function 9 x minus 9, its derivative is equal to 9. Therefore, the limit coming from the right and the limit coming from the left aren't approaching the same slope value. Our slope, although it's continuous, is not differentiable because our curve is not smooth at the value 3. Our slopes are approaching different things. Hence, f of x is not differentiable. Which would lead us to a conclusion that the correct answer choice, going back to the original problem, answer choice continuous but not differentiable.